Hello, everybody. Good morning, good evening, good afternoon. So really welcome to this year's PSC annual conference and workshop. So sorry about if you guys can turn off video. And I will kickstart to give some comments and give a short talk over here and warm up the whole team. Our arrangement for today's meeting is the later, the more like excited. That's the agenda we arranged. So let me get started from here. This is the first time. It's actually some of you log in a little earlier, so we are still preparing in the last moment. It's the first time we ran an online conference. And so really, it's a good opportunity to some extent allow us to gather more people globally, not only from physical on-site and OFC. Also, we have many friends log in from different part of the country and also from China, from Europe, from other places. So I want to start with the last 1-something years. It's a tough year, right? So for almost all of us, this global pandemic really is a unique experience. And we in US, especially in California, I'm based in the Bay Area, we're getting better. And but we know for many part of the world, right, still have all these different kind of situation. And we hope, we wish we can all get back to normal in the next few months. But on the other side, this unique pandemic situation also kind of like changed the industry a little bit. To big extent, we call create this we call the bandwidth economy. So for the optical industry, good or bad, actually drive more business, right? Many people start to work from home, and they need more broadband service, and all those big hyperscale companies, right? So there's no sign to slow down. They keep increasing, build more data center, keep adding all these optical interconnections within data center for switch router, so on and so forth. And the telco companies start to really get to the prime time 5G. All those things are actually a good news for the industry. And but on the other side, we do miss, this is the first time, right? Everything is, including OFC, is online, virtual. We miss this opportunity, all get together with friends, with customers, with vendors, with partners. And so we want to use this opportunity. We put together a very good a list of speakers we invited. It's the industry mover and shakers, right? So we want to hear from them with this new kind of like a situation, right? One side, business is getting stronger, demand is getting stronger. The other side, we have a challenge from the supply chain, mainly the semiconductor side, supply chain churn. From the transmission performance perspective, there's also, we're getting closer and closer to the Shannon limit. And there's a bunch of other things to show how do we deal with that. The very fast growing, right? So we need to go from 100 gig, 400 gig, even 800 gig down the road 1.6 terabits. So this is all these things in front of us. And we want to hear from this superstar team we put together for the workshop of today, gave us the insight for thoughts. So this is the major topic of today's conference. I want to start with to have a quick introduction of this whole committee, the Photonic Society of Chinese American. And I'm really honored to be part of this committee. And many of them actually the former president of this community. So some of them already retired, enjoyed a good life, and we really drag them back to volunteer their time, help the community. And many of us, we have a day job, very busy, very different hats. But I call many like Saturday calls to get together the whole team, really try to prepare this conference and invite good speakers and select the scholarship award, right? So all these things, we put a lot of effort, really appreciate the whole teamwork. And so we hope all you can enjoy this conference. Many of you maybe not even heard about the PSC. Sure. Well, I just want to briefly talk about the history, where we come from. This is like a 30+ year strong organization. It's totally non-profit organization, started from LA area back to mid-80s. Initially, it's not even for optical communication, right? So it's based on aerospace engineering and for some other photonics and many professors involved, and really drive this organization as how to help each other, how to build a relationship and help grow the professional and the business. So we started at the same time almost with optical fiber communication, right? So we by that time the OC3, right? So very old, 155 megabits per second. And then we get to the point of the internet bubble, the year 2000. And many of us in the committee still remember, right? So this is more like really the heydays. Optical communication hit the peak, and OFC, right? So the largest ever I remember is 2001 in Anaheim, 45,000 people shown up. People cannot even use cell phone, right? Run out of bandwidth. And then followed by that, it's obviously a bubble busted. The industry went too low. Our society also, right, getting into a surviving mode. And remember the very low time of OFC, we only have like, I don't know, like around maybe 1,500, 2,000 people. Many of them actually, right, come to the show and up around the different kind of booths. And so I appreciate we have this one leader, Norman, really helped carry, single-handed carry for almost 10 years, right? We went through the tough time together with the industry. And then second half of the first decade, we start to revive to back to growth again. And fast forward from 10 years ago, we back to the growth. And we more like start to put together this community again, slowly, every single year. The team's getting bigger and bigger. And we build up this tradition for the Wednesday afternoon of OFC week. We have a get-together workshop, followed by a big dinner. And we expand to many parts of the industry, right? So last few years, we reach out to like even, I think like 6 or 7 chapters across the US and China. So this is a really good accomplishment. And then we have this pandemic. So to a big extent, changed the whole picture of the industry and also changed our organization going forward. So what we did a few things. One is we re-registered. Instead of use the old name, we register as a Photonic Society of Chinese heritage, and really encourage a lot of professionals in this industry to get together because it's easier now online. And then we can organize more workshops, we can organize more seminars, right? So let people involved, even though you physically may be difficult to travel to come to OFC. It's a totally a non-profit organization registered in California. Everybody's volunteer, and our goal, our mission is to really try to pass around from generation to generation. How do we encourage younger generation to continue study photonics, continue jump in to help to solve the tough technical problem? And we're going to push the photonics, right, go beyond optical communication. We will, right, start to see the horizon for autonomous car, the LiDAR, car networks, and we see the horizon for the satellite communication. There's many new front photonics will help to solve. And so that's the mission. We try to gather a big community to help each other build up relationship, promote business, promote individual growth, their career. This is very important. In addition to our few hundreds active members, and we can reach out 1,000+ members, right? People who work in the photonics industry. We have a very strong support from the corporate community. And we are proud to list over here like 20, 25-ish company to sponsor us. And without this sponsor, it's really difficult or impossible for us to continue drive the organization, to continue providing this good conference workshop, to continue offering the scholarship to encourage younger generation. And I really appreciate all the support and help. But on the other side, we strongly believe we also can help company to develop their business, to promote their brand name, maybe even to some extent, right? Help them to acquire more talents down the road. But this is the one for this year, and I hope for next few years, we keep growing this list for all those company in this industry. So in addition to the corporate sponsored individual members in this community, we also strongly appreciate the partner organization we work together in last multiple years. And due to the time, I want to just introduce all of them together and then give each individual a few minutes to say some words over here. First is the OFC, right? So we actually grow the organization together with OFC. And this year is one of the, I don't know, maybe once of a decade, we have a chance to have a general chair of the whole OFC, the Chinese American, right, Dr. Zheng Jijie. We also, and treat us to some extent, a part of the OFC organization. And so we always coexist with the OFC week to run our workshop and annual conference. Next one is the CIOE CEO, introduced you to Eric Yan. CIOE, it's earned their fame for the last 20 years, grow bigger and bigger. Now I think it's, I only have one chance 2 years ago to attend. It's totally surprised me. It's more like a combined OFC and Photonics West, right? So it's like 80, 90,000 people shown up. And the last on this list, we are very, very proud to work together is the InfoStone Communication, introduced to Chairman Ming Shi. And he's well known, his organization really become more like a flagship brand to promote the optical communication, mainly in China. And to big extent, more like a China version of an executive forum, but it's like longer and bigger for their kind of like a yearly events. And so I'll pass to Chongjin to say some words over here.
Hello? Can you hear me?
Yes.
Yeah, go ahead.
Yes.
Thank you, Samuel, for the really nice introduction, especially for telling us the history of PSC. It has been a tradition for many years that Photonic Society of Chinese American hold a workshop at OFC. When I first attended the workshop many years ago, I found the workshop is very, very unique. Probably this is the only workshop so where researchers, engineers, business leaders, and entrepreneurs sit together and discuss new technology, new products, and market trend. And of course, with good food. PSC workshop always have good topics and good speakers. And this year, I think it's even better. I saw so many people attending online, even with just virtual conference. And we have 5 outstanding speakers. They will share their views and the future of our industry. I think the only regret is that we cannot enjoy good food together. I wish we'll have good discussions and enjoying the workshop. Thank you.
Thank you, Chenjin. So next is OSI CEO Liz. I'm not sure she's log in now. Let's show a pre-recorded video, and she will log in later for the workshop part.
Hi, everyone. I'm Liz Rogan, OSA CEO. It is my honor and pleasure to welcome you to PSC's annual workshop held in parallel to OFC. I have a couple slides to share. The first is a summary of topics that were discussed last week during the OIDA Executive Forum. 2 I want to focus on is the open and disaggregated networks. There are many talks about that during OFC this week. The key, of course, is how incredibly flexible networks need to be now, given the uncertainty of our times. Second is edge networks, which is the next extension of cloud networks. In our case, gaming has become a very big revenue stream, and networks have been optimized for high bandwidth or for low latency, but not both, and gaming needs both. For those of you who went to the 2006 OFC plenary, Bran Farron, Chief Creative Officer for Disney, was invited back after being away for 20 years to talk about his predictions. He asked for the house lights to be turned on, asked for a show of hands in the audience of how many of us were actually doing gaming. Maybe 25 people out of the 2,000 to 3,000 people in the audience raised their hand. The other slide I wanted to show is just a small summary of the content that is available at OFC this week. A lot of free content, the exhibit, MarketWatch, Data Center Summit, and of course the plenaries. And then the conference has some terrific content as well. Please don't miss the Quantum Key Distribution Symposium that takes place today, Thursday. And with that, I'll turn it back to the organizers, and I wish you a great program. And thank you for partnering with OFC. Bye.
Thank you, Liz. Frank, let's show the pre-recorded video for Eric.
Hi, everyone. Good morning. This is Eric Yang. I'm General Manager of CIOE. It's been a very great honor for being invited by PSC to deliver the greeting. Thank you so much for having me today at the Reimagined Optical Industry Forum. I will give a quick talk on what we observed from China as China's largest event organizer. Well, some of you might already know CIOE. We are annually held exhibition and a conference from Shenzhen, and the information communication technology consists one big part of our event. So if you are looking for the latest development of optical fiber and cable, CIOE will be a very ideal platform for you. From our perspective, for which I did study quite a lot of industry reports and had talked to a few people, generally speaking, the ICT market in China is still quite optimistic under the COVID situation. Even there's some setbacks for the supplier chain at the beginning of the pandemic, the industry starts to thrive as before real quick. Besides that, in China, there are 2 national policies to drive the industry. Both of them emphasize China's invest and determination in keep driving the ICT industry. But let's take a little step back and think about what's the very core of industry development. Personally, I believe that is the communications and the brainstorming from the brilliant mind. To complete that, we give our thanks to organizers like the PSC could bring us together for exploring the possibility together, and I hope you all will have a pleasant and insightful afternoon with today's speaker and the presentation. And I also hope we could meet together at CIOE in Shenzhen. Thank you very much.
Thank you, Eric. Let's welcome Xun Shi, Chairman Shi Ming.
Good afternoon to our honorable guest, Chairman Samuel, and good morning to Asia Friends Online. I feel honored to be here to present the InfoStone platform as PSC Asia promotion partner. Currently, I'm in Taiwan. As you know, Taiwan people are suffering coronavirus by lacking of a vaccine at now. We here learn a lesson. If you are not prepared well, the virus will drive you to the hell. Year 2020 was extraordinary year as well as 2021. First, coronavirus sharply impact the whole society, the whole social structures, living area was locked down, and a lot of people stay at the home without work. Second, the international confrontation among the leading countries make chip and supply chain drag down 5G network system progress. For the other hand, the hard lead is still there, working at home, discussing meetings through the video conference, and the traffic flow actually sharply increased. In China, 5G project catch up afterwards. As the end of the first quarter, China has completed a total 819,000 5G base stations, and 48,000 among them newly built in the first quarter. By the end of 2021, China planned achieve 10 million gigabits broadband user, and more than half of them are 10G pound and above. Global data center capex is back to growth. I saw the budget, the Q1, they have more than 30% year-to-year growth of large operators, the capex. Finally, I sincere wish the health and the wealth to you all and your whole families. I thank the PSC organized this workshop and hope it's achieved complete success. Thank you.
Thank you, Shi Ming. Okay, so the next section of today's conference is the Ting Yi Li Memorial Scholarship Award announcement. I will hand it over to my colleague, Xue Zhe. He lead the team together with Shifu and Steve, so to put a lot of effort behind it. Xue Zhe is all yours.
All right. Can you hear me?
Yeah.
Good morning, good afternoon, and good evening, everyone. This is Xue Zhe. I'm the current chair of the PSC Scholarship Committee. First of all, a brief introduction to the PSC Ting Yi Li Memorial Scholarship. As a lot of us know, Dr. Ting Yi Li was a famous scientist who made outstanding scientific contributions, who was also a great mentor to a lot of young scientists, who also did exceptional services to the photonics communities. To honor Dr. Li, to recognize outstanding graduate students in the fields of optics and photonics, also to encourage giving back to the community like what Dr. Li did, PSC set up the Ting Yi Li Memorial Scholarship since 2019. Next page, please. The scholarship is open to all graduate students worldwide in the field of photonics who have outstanding academic achievements, done substantial scientific community services, and a strong recommendation from their sponsors or advisors. To select the scholarship recipients, we have a scholarship nomination review committee formed by a group of world-class experts from both academia and industry. Professor Alan Wilner from USC, Professor John Bowers from UCSB, Professor Vincent Chan from MIT, Dr. Hong Ho from Intel, and Dr. Xiang Zhou from Google, as well as the PSC Internal Scholarship Committee, including me, Dr. Xu Fuyuan, and Dr. Steve Yao. This year, we had 6 competitive candidates from universities and research institutes across the world, reviewed and voted by the Scholarship Nomination Review Committee and approved by the PSC Board of Directors. We have 2 outstanding young scholars as the winners of this year's scholarship, Chao Xiang from UCSB and Ranzhou Zhang from USC. Chao has 8 first author publications in science, Optical, and etc. He has gained worldwide recognition for his accomplishments in silicon nitride PIC. Ranzhou has 9 first author publications. He has made significant achievements in free space communications using structured light. He has also done great community services to PSC and other organizations. Congratulations, Chao and Ranzhou. With no further ado, let's welcome the first scholarship recipient, Chao Xiang from UCSB, to say a few words about himself and his work.
Thanks, Dr. Zhen, for the very kind introduction. And I'm Chao Xiang, a PhD student from Professor John Bowers Group at UCSB. And it's my great honor to be here virtually today to receive this Tin Yan Li Memorial Scholarship. And I heard the story about Dr. Tin Yan Li many years ago while I was still an undergraduate student in China. So Dr. Tin Yan Li has a fantastic scientific career, and also he's very famous because he's dedicated to the development of the entire photonics community. Dr. Tin Yan Li is no doubt a role model for every young student in photonics, and including myself. So currently at UCSB, my research focuses on the development of heterogeneous integration with silicon and silicon nitride photonics. So here are some research highlights of my work. We made very widely tunable 3.5 on silicon lasers with over 110 nanometer tuning range and below 100 Hertz Lorenzo line width. And also we made the first demonstration of heterogeneously integrated laser with silicon nitride cavity, and also the first heterogeneously integrated laser soliton microcom devices. So if you are interested in all this work, you are very welcome to check the recorded talk video happened today at OFC. And Dr. Tin Yan Li actually has a very famous quotation saying, good physicists should upgrade themselves into system engineers. So I think this is a very strong inspiration for myself to transform my research into real-world applications. And I believe today's scholarship is a new start for myself to do better research and also serve the community better. And I want to thank the PSC again for this great honor on this award. And thank you.
Thank you, Chao. Next, Ranzhou, are you online?
Hi, Shizhen. Thanks, Shizhen. Thanks for the kind introduction. I'm Ranzhou from University of Southern California, and I have been doing research in the field of optical communications. My advisor is Professor Alan Wilner, and my research is basically focused on enhancing the capacity and the spectral efficiency of optical communications using structured light. And I have been presenting my works in overseas during the last 3 years. And I've been attending PSC workshops during the last 3 years as well. So just as Treasure and Chao mentioned, Dr. Tin Yan Li has been really well known worldwide for his contribution to the field, as well as to the helping and mentoring young scientists. So I'm really honored to receive the scholarship, to receive this Tin Yan Li Memorial Scholarship, and I really appreciate the continued support from PSC. And I would definitely keep the effort, and I would do my best to continue to contribute as well as serving the community in my future career. Thank you.
Great. Thank you, Ranzhou. Let's congratulate Charles and Ranjo again. So before I end this session, let me thank the Scholarship Review Committee again for taking time out of their busy schedule to do the evaluation and select the recipients. Thank you.
All right. Thank you, Xue, and congratulations to Chao and Ran. Let's not give any further delay, move to the anchor program of this conference, right? So I wanna introduce the moderator, Dr. Ryan Yu, and he's also the Vice President of this year for PSC. He's the Senior Vice President of Photonics. Ryan, it's all yours.
Okay, yeah, thank you, Samuel. I'm honored to moderate this year's PSC workshop, titled Reimagined Optical Industry. So as Sam mentioned, most of us have been working from home for last year, endure some of the pandemic related issues, but I think we all can hear some good news. More bandwidth definitely got demanded during the pandemic. And as a matter of fact, we're using Zoom today. Zoom is one of those companies really going through the booming time because of networking. It really become one of the now critical infrastructures for the whole societies and across the globe. China and US is going strong 5G deployment. And then in data centers, we're going to hear today, going through another round of transition to 400G, even 800G is looming in the background. Silicon photonics is another new emerging area for our industry, and it's going practically mainstream. And in general, I think optical networking demand is strong, and I think as an industry player here, we all can enjoy this newfound optimism for our industry. However, there's also some looming disruptive force going on, including some of the geopolitical issues going on. Supply chain is going through its realignment, and good news also, China and US have a refound emphasis on investment in hard tech, to some extent responding to the demand, but also somewhat disruptive geopolitical issues. On the technical front, with this new integrated silicon photonics emerging as a mainstream, certainly there's emerging discussion in the industry about co-packaged optics, which may become a disruptive force to the existing supply chain and ecosystem. And in the application front, we will actually start to see a telco service provider and web companies may start a battle in so-called edge computing and edge data center front. So we invited today an esteemed industry leaders and experts to share with us their views of the future for this reimagined optical industry. We are honored and happy to have Dr. Hong Liu from Google, Dr. Ming Sun from Tencent, Dr. Hong Ho from Intel, and Dr. Li Xu from II-VI, and Cayman from Cisco. Please join me to welcome our panel speakers.
那我就先开始了。今天这个分享的这个报告呢，其实是之前 Frank 告诉我，然后我觉得这个题目挺有意思的，然后刚好结合最近我们内部在思考的一些事情、一些问题，然后相当于提出一些东西吧，提出一些观点，或者提出一些修一些现状吧，大概是这个意思。当然，这个东西，这个 PPT 不只限于我们就当下讨论这个 communication， 整个光学的这个 industry 都会涉及到。对，中国有一句古话叫旁观者清，就是我们在思考，比如说这个 optical industry 过去的若干年以及未来的若干年的时候，我们经常需要去跳出来去思考一下，就是大家最关心的几个问题了，无非就是3个问题。一个问题是这个 是这个就是有没有 business growth， 有没有一些新的领域啊，一些新的机遇，然后呢，我们如何去获得这些机会？对，所以我这里呢用了2个例子吧，去表达一些观点。首先呢，这个整个这个光通的这个首先呢，整个这个光通的这个产业，光学的这个产业，不是光通的产业，就是我大概列举了一下，大概分了这4类了，包括显示，LED 啊 ，AR、VR 啊，还有这个全息啊，然后包括 sensor， 包括这个 biosensor， 包括 LiDAR 呀，包括安防啊这之类的。然后呢，我们可能更多聚焦在这个 communication 上面，包括现在的有线、无线的光通信，还有这个大家现在提到特别多的 processor， 然后还有这个其他的一些领域，比较传统的这种激光相关的一些领域。对，大家就是非常关心的是，就是或者大家特别提到的一个观点，就是哪里有增量，就是包括像我们前些年提到比较多的 LiDAR， 包括这个 AR、VR， 这些都是潜在的一些对于光学这个领域有增量的一些东西，包括这个未来的这个光子计算这些领域。对，所以其实大家可以不只限于就是 communication， 可以整个，因为大家立足的是光学，那可以整个去看到这个所有的光学领域的应用，因为很多东西是相通的。然后这个是一个例子，就是讲 data center， 就是可以这样讲，就过去的10年是一个数据中心快速发展的10年。那究其根因呢，其实是移动互联网快速发展的10年。包括像这个最下边这张图，就是讲了腾讯的这个过去10年的发展。比如说这个我们2011年我们这个推出了微信 WeChat，然后2013年我们有了这个手游，有了这个手机版的 QQ 啊 WeChat 的这个游戏中心，然后2015年有这个就是 Pony 提出了这个互联网加的概念，然后呢它也是作为一个国家战略。然后这个2018年我们专门成立了这个 CSIG， 我们叫云与智慧产业。然后呢2018年以后，我们的基本上所有的这个网络设施就开始转向全面的自研。对，那在这个背后，就是在业务驱动的背后，其实就是一个这个就是带宽的一个不断的提升。可以看到第二张图，就是我们每年的这个城域网的带宽的这个总的这个带宽大概每年翻倍的这样一个增长趋势。对，然后最右边这个图呢，其实是 LightCounting 最新的这个 report。其实可以看得到，就是基本上这个产业，光通的这个产业的这个，就是说 module 这个产业的一些变化，就是随着数据中心的一个快速发展，然后呢，基本上出现了一轮新的洗牌。过去的这个10年，中国有句古话叫“天下大势，分久必合，合久必分”。其实这个用来形容，就是我们现在遇到了这个境遇，或者是我们在这个交换机和光幕画这个相互的这个关系上面，我觉得是比较贴切的。因为这样的就是以前呢，我们的这个交换机光幕画全部是通过这个系统厂商或者设备厂商去购买的，就它基本上是一个这种黑盒的状态，可以讲就是完全集成化了，然后呢成本非常高。随着其实这个数据中心的发展，还有大家对于硬件这块的重视呢，然后出现了这个硬件解耦。硬件解耦呢，就是把这个交换机然后自研，把光幕块呢就是直接外购，然后呢把接口的这个协议大家协商好，然后呢就是一个低成本，然后呢可差拔的一种解决方案。但是呢，现在大家提到特别多的叫 co-package， 其实 形式上可能是为了解决比如说高密度、高容量的问题，然后呢，但是实际上对于整个产业链来讲，它带来的一个问题就是它又回到了原来的这个叫 switch system 这个状态，就是完全的集成化了。那谁来提出这个解决方案呢？虽然是由可能 end user 就是我们来提出这个完整的解决方案，但是整个生态链呢，其实相当于或者相对来说已经形成了一个闭环。当然这个东西像刚才这个刘洪博士讲的，这个东西每个公司有每个公司不同的看法，所以我只能说在这里提出一些观点吧，或者是提出一些现状吧。对，然后这一页呢sorry， 这一页呢实际上是一个架构的演进。然后呢，可以看到我们过去的这个或者这样讲，我们的每一代的架构演进基本上，或者每一代的设备基本上是5年的这个生命周期，从10G base 时代到25G base 到50G base， 基本上可以预见到的是5年的一个生命周期。那其实究其最根本的，一方面是数据带宽的这个需求提升，一方面是 ASIC 芯片的一个演进，基本上 ASIC 芯片2到3年一代的演进。大家其实最关心的就是未来的这个若干年，5年、10年，大家会走到一个什么样的一个模式？其实宇博，我不确定这个地方这个地方能看得到吗？宇博，
可以看到你的 slide。
完整的都可以是吧？因为我这边看不到完整的。
我们可以看到完整的。
OK， 所以应该这样讲吧，就是大家可能举个例子，大家可能现在比较关心，比如说像当然刘洪博士也在了，就是大家可能比较关心像为什么北美在用400G， 甚至马上就要用800G 了，那为什么国内还在用200G 或者400G？或者200G 还刚开始，400G 刚开始。其实大家用的这个 ASIC 是一样的，但是呢，大家的这个设备的形态是不一样的。比如说像这个 25.6T 的 ASIC， 那大家可以用了32口，然后800G， 每个口800G， 可以用64口，每个口400G， 可以128口，每个口200G。这个其实根据每个公司的架构设计而定的。那其实根据这个，我们再来看，就是未来10年的一个趋势。我们会发现，比如说我们继续沿用128口这个形态的话，那我们到了2027年的时候，也才到就是128口800G 的这种形态。也就是说，可能未来10年我们都不会遇上 CPU 这种东西。所以，其实提到刚才那个问题，就是 CPU 到底什么时候来 ？CPU 到底这个会怎么样？那可能每个公司的布局都不一样。最影响的，我相信应该是就是我们自己内部的架构的一些演进，还有业务的一些需求导致的这个设备形态的一些变化。当设备形态发生了变化的时候，CPU 有可能会到来。刚才讲了，就是这个就是不只是限于，因为这个 topic 是 Optical Industry， 不只限于说光通了。那我这里也举了一个就是以前研究过的例子，以前在华为的时候就是做过一些研究，然后呢，其实大家或者是很多人比较这个关心的问题就是我们的这个 Optical 是 to B 的还是 to C 的？For example， LiDAR 或者是 AR、VR， 或者是这个就是其他的一些，比如说全息啊什么这些东西。它是 to B 还是 to C 的？因为究其最根本的问题或者最本质的问题就是 to B 和 to C 最大的区别在于谁来定义产品。过去的这个10年或者过去的若干年，to B 是一种叫这个供应商来定义产品，比如说这个产品是黑盒的状态，那由产品供应商来定义我有什么产品，你来用就行。to C 是用户来定义产品，就是我有什么需求，那大家来做，就是这个终端用户 但是呢，随着这么多年的一些变化，那完全形成了一个反转，就是 To B 变成了这个用户来定义产品，比如说像我们的这个 OTT， 就是像这些互联网厂商，他们在定义他们的自己的交换设备，定义自己的互联的硬件，定义自己的播分的设备。那像这个 To C， 最典型的其实就是 Apple。他在定义自己的产品，他在引导用户，引导这个消费者去 follow 他自己的这个标准 ，follow 他的这个 style。所以呢，其实 To B 和 To C 对于这整个光的这个 industry 来讲，我觉得是你的选择是比较重要的。但是其实这个 To B 和 To C 是比较模糊的一个定义。比如说 LiDAR。这里讲 LiDAR， 就是 LiDAR 其实它分很多不同应用了，包括这个辅助驾驶 ADS， 然后包括这个 automation， 就是这个工业自动化，包括一些智慧城市啊，包括 mapping 啊，其实不同的这个应用，它可能代表的是 To B 还是 To C 是完全不一样的。所以呢，其实在 LiDAR 这个选择上是一个比较重要的一个环节。那就 LiDAR 本身来讲呢，我觉得这个 From Yellow 就是有一个这个 report 是这个预测未来10年的一些变化了。那比如说像这个2012年的时候，其实还没有 LiDAR 这个东西，就是大家还是用的这种有的也是这种就是no scanning， 就是不是扫描的这种方式。然后17年的时候呢，有了这种机械式的，然后呢距离很长，但精度很差。然后呢，大家一直在把这个 LiDAR 推向成熟，包括像近些年的一些这个 FM 的，包括这个相宜的呀这些方案的一些这个成熟。然后未来呢，大家肯定是趋向于这个做短距、长距，然后中距，然后这些分级，然后不同的这个应用场景。然后呢，不同的精度要求，对，但是其实还想说的一点就是说，如果你是 To B 的，就刚刚讲的 To B 其实是 user defined product， 所以有一个很重要的一点就是大树底下好乘凉。中国有一句话叫大树底下好乘凉，就是大家未来一定是一种抱团的模式。出现了，无论是注资，无论是这个收购，还是一些战略合作，就是这些小的 LiDAR 公司一定会去帮着这些，就是无论是系统厂商还是终端用户就是 business 的终端用户，大家一定会往这个方向去发展。我想到这几点了，就是第一个就是要赋予这个光更多的系统特性。第二个就是让光更加的独立，而不是去依托更多周边的一些东西。然后第三个就是让更多的这个终端用户去理解它，因为很多人对光其实是并不太理解，或者对于光的这个系统并不是太理解，他认为这个东西是一个not very important。对，所以谢谢大家今天的这个聆听，我的报告是这样的。
谢谢孙敏博士。Yeah, thank you, Dr. Ming Sun. Frank, can we bring up the next speaker, please? Let's do a quick intro. Dr. Hong Ho is currently the Corporate Vice President and General Manager of the Connectivity Group at Intel. His current responsibility is to deliver leadership hardware, software, and system products and technology, including Ethernet NICs and controllers and silicon photonics, Ethernet switches, and high-performance fabrics. Prior to joining Intel in 2018, Hong was Executive Vice President and Chief Technical Officer for FiberNet and President and CEO of Anchor Corporation. Early in his career, he conducted research at AT&T Bell Lab and Sandia National Lab. Hong has over 200 publications in technical journals and several U.S. patents. Hong holds a PhD in electrical engineering from University of California, San Diego. Let's welcoming Dr. Hong Ho to give us a speech on silicon photonics and ideal platform for optical transceivers, co-packaged, and optical I/O.
Thank you, Ryan. I should have given you the longer version of the bio. I got the wrong presentation on my screen, so you bought me some time. Can you see it now? The silicon photonics and ideal platform.
Yes, we can see.
Perfect. Thank you. Yeah, thank you for the invitation from the organization committee. And this has been one of the highlights of the optical industry. And you guys have been doing a great job in keeping up the tradition. And special shout out to Norman, has been carrying this tradition over many OFCs. Also, thank you, Ryan, for the invitation. So today I wanted to talk about silicon photonics, as you mentioned, that 20 years ago, that may be considered as a scientific curiosity, but now we are happy that we are considered to get on the main stage of the optical play. Dr. Sun mentioned about a lot on the optical sensing, LiDAR, and optical computing even applications, but I'm specifically talking about the data center connectivity, the silicon photonics used to connect the Ethernet ports in the hyperscale data center. And Dr. Hong Liu mentioned about the market driver. I wanted to reiterate the two aspects. One is that the hyperscale data center is getting even bigger. This is the published data of AWS from 2016. At the time, the hyperscale was considered 32,000 servers. 3 years later, the hyperscale increased the size by an order of magnitude. And also, a friend in Facebook, the computer getting more complex, the heterogeneous computing to deal with a different type of workloads. Have the CPU, and Hong mentioned about TPU and GPU and the accelerators for AI. But either case, the data center demand has increased dramatically. But even within the data center, for example, the AI accelerator cluster, so you have the scale up to increase the speed of each node, but you also need to scale out. For example, one cluster, you have 1,000 processors. The processors need to be connected through the switch using optical transceivers and to deliver the connectivity. And better yet, is low latency, low power, and high speed. And of course, the reach has never been an issue with a single mode. So this is really tremendous market driver, and also drive the higher speed, more channels, and higher degree of integratability. We all know silicon photonics is basically where you can achieve some photonic device functionalities like modulators and splitters and detectors and on silicon, and to leverage the CMOS manufacturing processes and scalability. But you can integrate electronics with the silicon photonic devices. So some companies are focusing on that level of integration, photonic devices with electronic devices. Lasers in optical amplifiers is somewhat different, because the silicon can do a lot of things, but it can't make it glow. So we have to use a traditional material, like 3-5 compound semiconductor quantum well material. And Intel has developed a process, a manufacturable process through wafer bonding to get this dissimilar material integrate onto the silicon. So this way we can do subsequent processing on already processed photonic circuits, wafers, to get the lasers integrated. And we can leverage the CMOS scale on 300 millimeter substrate, we more importantly can use on-wafer optical testing, electrical testing, high speed, and most recently, we have implemented wafer level burn-in. So the devices after the wafer level processing will be identified, be able to identify the non-good die with the optical performance meeting our specification and fully burned in and weeded out any weak parts. So that makes the optics manufacturing at scale possible. Today, I wanted to just touch base on the three different aspects: pluggable optical transceivers and co-packaged optics. The two previous speakers mentioned a lot about that. And also, I wanted to extend that even further, talk about optical I/O. The pluggable transceivers is pretty straightforward. As Hong gave the overview, the evolution over the last decade to match up with the different switches. So, and then the CPO is commonly mentioned to integrate with the Ethernet switch die to save power, to get a better bandwidth density. And optical I/O goes further than that. It can be integrated in with any ASICs processors to provide better bandwidth density, stored density, reach, latency, and power, which is really, really very important because you look at transceivers, pluggable transceivers typically offer about 30 picojoule per bit, but optical I/O needs about 2 picojoule per bit. So the pluggable optics give you the convenience, give you the serviceability and interchangeability, but doesn't give you the power required for high density assemblies. First, on optical transceivers. So we have been a provider of optical transceiver of 100 gigabit QSFP form factor since 2016. To date, we have shipped over 6 million optical transceivers, and we have the run rate typically at about 2 million per year for 100 gigabit. And we do primarily two flavors: parallel single mode or CWDM format. And it's a very established process and very established product. It has been in volume production over the last 5 years. And the field response has been extremely positive. I know some of my customers is in the audience, and you will agree with me that the reliability of the Intel silicon photonics transceivers is really setting a gold standard for the industry. It had a very, very, very low failure rate. And we introduced 400 gigabit DR4 into production. And so this is really using the PAM4 modulation and have 4 lasers operating in the same wavelength. And we certainly have a version to be offered later this year to have a CWDM version. So we call it FR4, 400 gig. Has the lasers operating at a different wavelength in the O band. And so they combine into one fiber, and they have the dual mini LC fiber connector to significantly reduce the number of fibers needed. And this is already in the volume production and supply to hyperscale data centers in volume. Move on to 800 gigabit. Since we have been able to optimize the performance with the PAM4 and Mach-Zehnder modulator in silicon photonics, we're able to scale it up basically by 8-channel lasers. This can be parallel single mode and give you 16 total fiber counts through an MPO connectors. This is already in sampling, and I think that the OFC demo or virtual demo, we have a number of customer partners are demonstrating the performance of our DR8 transceivers. And since I mentioned that, you know, the modulation scheme are the same and only the laser wavelengths are different, of course, we have to be mindful about the link budget and through the MUX and DMUX for the CWDM version, but we are able to achieve the performance. And we have the samples running in the lab, and we'll be able to provide the samples to the customer very shortly. Again, this is the dual mini LC 4-fiber version, 2 transmit, 2 receive, 2 sets of CWDM4 in a way to modulate at 100 gigabit per channel a speed. So that's 800 gig. As Hong mentioned, you know, moving on to say 1.6 terabit, you can certainly do 16 channel version of 100 gigabit per channel, which I will show in the next slide. But we have demonstrated the capability of using ring modulator. So I understand the concerns of Mach-Zehnder modulator may need higher voltage to drive and maybe a little longer in order to achieve the extinction ratio. But the ring modulator has been a very established device at Intel and pioneered by Intel Labs several years ago. So later on, I will discuss the ring modulator. We have demonstrated 100 gigabit per channel PAM4 for 16 channels. That's one way to get into 1.6T. But recently, we have demonstrated 200 gigabit PAM4 from the ring modulator. So you see the simulated I and you see the measured I from this limited by the equipment we borrowed from Keysight. But we are very confident that we can achieve 224 PAM4, 200 modulation by PAM4 from the ring modulators. So this, if we do 8 channel and 200 gigabit per channel, we will be able to get into 1.6 terabit per second and fit into the OSFP envelope. So next, a couple of slides, I will talk about the CPO, co-packaged optics. As I mentioned, the motivation of that was primarily driven by customers' needs to reduce power consumption in one RU box. They wanted to have the radix and density they have definitely within the rack. You know, the power consumption of electronics and optics is a small portion of the entire data center. But within a one RU box, the optics account for more than half of the power consumption. So if we can bring the optics closer to switch die, we do not need to recover a lot of losses, incur a lot of losses through the PCB trees, especially when the transmission data rate is high, like 100 gigabit per second. And we can possibly remove the CDR as well. So that this two alone will give you about 6-7 picojoule per bit advantage. So here last year, we were planning to do the OFC demo. We got them ready, and but OFC was delayed. So what we ended up doing is invited some key customers to our laboratory and to see the demo of 1.8 by 1.6 terabit per second photonic engine integrated with the 12.6 terabit switch that's underneath this block. So here I showed 4 photonic engines, and because this site, we wanted to get the flexibility of the have a flying wire and connected to electrical plugins. So there's here the optical ports. Each one is 1.6 terabit. And the whole 1.6 terabit engine is at this size, and then has the connectors and to the single mode fiber. And it was an excellent performance. This is again using the micro ring resonator as a modulator. Each one is operate at 100 gigabit per second. We have integrated monitoring diode. We have lasers. And here we only need 16 lasers, but since we use the same slab of indium phosphide, and the laser cavity is easily defined on silicon, so we actually have 100% redundancy, have 32 lasers in there, just in case burn-in process and some of the lasers get out of the spec. And so this is a laser array and a mode converter, and we use a passive alignment and to get the light out through the V groove. And of course, for this many counts, the packaging is very important. A good thing is Intel, we have really good packaging technology that almost provides another dimension of freedom in design to ensure the signal integrity electrically and optical stability. So we had a lot more information on the co-packaged optics. Now the industry really view that, well, the 12.8 terabit, you can use one RU and 32 400 gig ports, and the power management, it can be controlled within 1.7 kilowatt within the box. That's fine. So there's really no need for co-packaging at that bandwidth. But there are a number of customers seriously considering to bring optics closer to the switch die at a 51T bandwidth. So to us, the important thing is that Intel, we provide the CPUs, we provide GPU, we provide other processor units, and Hong mentioned about TPUs. In all of these processors, you will have more and more compute capabilities. So right now you're integrating 25, 30 billion transistors in one processor, and you need a lot of I/O to get the signals out. And you will run out of shoreline space to get the electrical signal out. And also, if you do the SerDes, serializing, deserializing, and have the I/O die integrated, you'll burn a lot of power as well. So we have an architecture to use the EMIB, embedded multiple channel interconnect bridge. So basically get it a low speed parallel signal conducted out through a slab of multi-layer silicon. And then on this side, get them connected into one IC, which has the drivers and TIAs and SerDes, and also PMIC. And then the photonic integrated circuit will be all on one piece. And this can be 16 different lambda lasers, go through the supernova configuration to have 256 channels. Each one of them can modulate, NRZ at 64 gigabit per second, or PAM4 at 100 gigabit per second. That gives you tremendous bandwidth. So really, each fiber can carry 1 terabit per second bandwidth, and you can have 16 fibers. You just have a lot of bandwidth there. You can reach to 2 kilometers, no problem. You can have a shoreline density higher than the highest electrical I/O can offer by a factor of 6. Power efficiency, as I mentioned, is very important when you have that many I/Os and that much bandwidth. Latency can't really do a whole lot in time of flight, but without the FEC circuit, we'll be able to reduce the latency pretty significantly. So that's why the NRZ modulation is preferred. As I mentioned, the packaging technology at Intel, we can definitely use that in chip level packaging, electro-optical packaging, and this has become really a very critical play of the packaging. That's why silicon photonics is critically important for this because of the integratability. So Ryan, I will just put this slide here. So to summarize, by optical transceiver applications and CPO and optical I/O. So that's our focus at Intel at this point. In addition to that, we probably have the most advanced frequency modulated CW LiDAR, which offers 200-meter ranging and with a superb frame rate and resolution. So that's based on silicon photonics as well. Thank you.
Thank you, Han. Great talk. Certainly, you bring everything silicon photonics is about on the table here. Yeah, Dr. Li Xu is currently the Senior VP and General Manager of Transceiver BU in 26. Since 2008, Li has served on various positions. He Finisar 26 acquired Finisar just recently. He was General Manager of Finisar Shanghai, Wuxi, General Manager of Data Networking BU. Previously, he worked as a fiber optical component R&D engineer manager directors with increasing responsibility for several companies, including Hewlett Packard, Tyco, Intel. He co-founded a startup company, Paracer, in 2000 on high-density optical interconnect. Paracer was acquired by Stratos Wave. Li holds a bachelor degree from Tsinghua University and PhD in electrical engineering from Princeton. He holds 15 US patents. Let's welcome Dr. Li Xu to discuss how to thrive in the ever-changing environment for high-end transceiver.
Good afternoon and good evening to folks in US, and good morning to everyone in China. It's so nice to meet everyone in this online meeting. I concur with what Dr. Xie said earlier. I hope that we could get together for dinner next year. It's definitely a great honor to have the opportunity at PSC to share some information about our 2.6 transceiver business and share some of our thoughts with you. The previous speakers talked about the general technical and business trends. And it's very insightful related to optical communications. I would like to provide a view just from a long-term transceiver supplier. Next page, please, Frank. So this is the outline of today's talk. I will first give a quick review of 2.6 transceiver business over the past years and our current status. We'll share our observations of the changes during the years. I will then show our roadmaps and some of our approaches to address the current market demand and challenges. At the very end, I'll give a very brief summary. Next page, please. Okay, so this page shows the revenue growth curve of Finisar before it was acquired by 2.6 in 2019. From year 2000 to 2018-19, Finisar grew from about $100 million to over $1.4 billion. It became the largest transceiver supplier after 2008 when it acquired Optical. We had a bit dip and flat years in 2018 and 2019. And so after it was acquired by 2.6 in 2019, we've been seeing healthy growth in our transceiver business. And that's reflected in the overall 2.6 performance and the stock price. During the past 10 years, we keep the #1 position for transceivers, but the landscape around us changed significantly. Our main customers used to be enterprise OEMs like Cisco, Huawei, and Juniper, and EMC, company like that. Now the hyperscale data center customers become very important in addition to our enterprise customers. We also see, in some cases, our customers are starting to making transceivers like Cisco and Huawei. And 10 years ago, majority of our main competitors were US and Japan based. Now over half of them are China based. And we used to see fierce price competition at low end of the market. Now that's extended to high end also. And our supply landscape also changed. Optics used to be a relatively small field, so it did not attract a lot of independent IC and laser vendors. But now there are many, large companies that's providing ICs and lasers independently. And Dr. Hong Ho was just talking about the silicon photonics from Intel. That's certainly ramping to very high volume. Another example is the former Avago. I used to only produce optical chips for internal use. Now it mainly sell externally ICs and VCSELs and other type of lasers. So there have been profound changes in the last decade from our customers, competitors, and suppliers. In our own company, our R&D and operations also underwent huge changes. We used to concentrate the transceiver R&D work in US, and now we're doing that in both US and Shanghai. This allows us to leverage the strength of R&D teams on both sides, and we've been reaping good benefits from that. On the manufacturing side, we used to have almost 100% transceiver level manufacturing in Malaysia. Now we have large factories in both China and Malaysia. In addition to our pursuit of innovation and our scale and our emphasis on quality, the above adjustments are important for us to keep the #1 position in transceivers. So another change is that with 2.6, we still have the vertical integration that we have our own VCSELs, DFBs, EMLs, and tunable lasers, ICs. But in the meantime, we're open to sell these on the market. And we now also, from transceiver level, need second sources for our lasers. And we believe this change of strategy overall is better for our company. So next page, please, Frank. So this one shows our datacom roadmap, right? We're staying at the forefront of each major generations. In the previous talk, both Dr. Hong Lu and Dr. Ming Sun talked about the need from customers, and we're certainly engaging very closely with the top hyperscale customers. Right now, these hyperscale data center customers are the first ones to use the most advanced products. So we align our roadmap with them. And 200G, 400G, 800G are quite clear now. And I want to chat a little bit about the 1.6T. Dr. Hong Lu talked about that, and there certainly have been very serious discussion and R&D effort on making 200G per lane optical devices. And 2.6 is investigating making prototypes on both 200G EMLs and 200G laser and Alexander based on indium phosphide. And so customers want to see that in 2023 and 24 timeframe. And we are, in addition to laser and other development, we're working with customers and vendors on this. So the roadmap could change over time, but the general trends is certainly there. And we do not see any slowdown in the pace of innovation here. Working with the high, scalers, hyperscale scalers, fast and high quality R&D execution is a must. Furthermore, a fast production ramp is necessary to catch the sustainable level of profits. So, next page, please. Thank you. So this page shows our coherent roadmap, right? And this is for the next few years. We have some advantage here that our Sweden team produces integrated tunable lasers and indium phosphide Alexander modulators. And we focus our efforts on high-powered ITTRX and IC TROSA. Both integrate coherent transmitter and the receiver together, mostly addressing the 200 and 400G market. We've been growing this business significantly in the past 2 years. We certainly see that people are using coherent in shorter and shorter distance at higher and higher speed. We're glad that we can participate in that. And as Dr. Hong Lu mentioned earlier, we believe that coherent technology will get a wider and wider usage. So 2.6 has a very large kind of a transceiver business, and we have been working closely with our customers on the roadmap of products. But in addition to that, we're doing several things trying to provide more values to our customers. Right? Please allow me to give a few examples. In the following 3 pages, I want to show one example of our unique designs, our kind of vertical integration, and our broad and diversified product portfolio. So thanks, Frank. So this example shows an advanced VCSEL-based packaging design, which we're doing for a key customer. We've had a significant business of VCSEL-based onboard optics with supercomputer customers in the past 7 to 8 years. As we shrink the size and increase the speed, our development could potentially be used for some applications in co-packaged optics. Certainly the current kind of mainstream talking about the co-packaged optics is using silicon photonics. We believe on some applications, the VCSEL-based might have a good fit. And on this particular one, we're trying to squeeze as many as 32 channels of TX and RX 100G per lane into a very small package. Next page, please. This page shows our vertical integration. Yeah, this is we have many lasers and ICs as well known in the industry. Next. Yeah, and in addition to the active components, we also have passive components like isolators, DMUX, and micro lenses, lens arrays, and stuff like that. And we certainly have our own factory to do sub-assemblies. And for example, our coherent is a kind of a 3D complex assembly, and we've been honing that product for the past few years. And next, and with all these sub-assemblies, we manufacture majority of our own transceivers, right? And the vertical integration does keep give us cost and ramp up speed and quality control advantages. Thanks, Frank, for the page 8. This one shows, can you go back to page 8? This one really shows our, in addition to transceivers, shows our broader product offering, right? And in addition to being #1 in transceivers, we're in general #1 in optical transport. That's including transceivers and pump and amplifiers and WSS products and ROADM. And so altogether, in overall communications, we have the broadest portfolio offering to customers. Here, I just want to give one example, right? And we can kind of provide a lot of the key components for our customers to have the full system, right? If the company needs kind of DCI connections, they can buy from us all the way from transceivers to ROADM to amplifiers and some coarse integration, circuitry. Right? That's what we're trying to use that to provide more values to our customers. So next page, please. Okay, so I want to give a brief summary of what Finis 2.6 can provide. And so we have the largest scale in the industry, and with that, we hope to serve customers with a comprehensive set of products and competitive price. And our vertical integration in lasers, ICs, and our own factories provide us with cost advantage, supply security, and agility. And our manufacturing and R&D are both geographically diversified. That gives us actual strength in today's environment. And we have the leading lasers in gallium arsenide, that's the VCSELs, and indium phosphide based. And with today's highly competitive environment, we rely heavily on our operational excellence, honed through the past 2 decades in R&D, manufacturing, and marketing, and sales to serve our customers well. And we have to consistently enhance that in order to stay competitive and stay ahead. That's my summary. Thank you very much again for your time and attention. Thanks.
Thank you, Lee. Really appreciate your insightful discussion. Let's bring Kay Min from Cisco as the next speaker. Kay joined Cisco investment team in 2011, is responsible for all Cisco's acquisition investment in core hardware, optical networking, silicon. We continue to display dramatic increase in speed, component integration, hardware system. Kay also has geographical responsibility for Canada. Her extensive experience in roles of increasing responsibility in product development, product management side of optical networking include both large companies and startups. A transition into investment banking and venture capital investing further broadened her experience. Kay has an MBA, BS engineering in ceramic engineering. Let's welcome Kay to discuss Cisco's investment in optics and silicon. Thank you.
Hi, everyone. I apologize. I thought that we would stay on time, so I've got childcare responsibilities in 15 minutes, so I'm going to have to keep this a little bit brief and probably can't stick around too long for Q&A. But what I'm here to discuss is the evolution of optics and optical systems for Cisco. with a perspective around leveraging inorganic growth opportunities such as acquisitions and venture investments in startups. Next slide. So I think my colleagues on this panel have talked about what are the drivers in the internet growth. So I'm just going to talk about this pretty high level. There's about a forecast about 5 billion people connected to the internet by 2022. That represents about 60% of the world's population. So about 40% of the population, or 2.5 billion people, will still remain unconnected. So we have a little bit of work to do to get the internet accessible to the entire world. Of that 5 billion or so, they're going to be driving almost 30 billion devices and connections. And they're going to demand faster broadband speeds. And they're driving high video consumption for the most part. And that's driving this exponential increase in the need for bandwidth. If we take a look at the traffic going in and out of the data center and through the data center, as everybody probably already knows, the majority of the traffic is east-west that stays within a data center. So about 70% of the traffic today stays within the data center. The remaining 30% split about half and half between data center to data center traffic, so inter-data center traffic, as well as data center to user traffic. And the reason why we point this out is that that east-west traffic in the data center, that's what's driving the need for the short-reach optics and the higher speed and short-reach optics. Next slide. So where does Cisco play today? We play in both intra-building, so within the data center or within a service provider central office, as well as in metro regional long-haul networks as well. The landscape in terms of what equipment and what technologies are used is different between the two main landscapes. Within the data center or intra-building, fiber is plentiful. So when we want to light up a service, we just plug in the new optics into the available ports. The distances are short, less than 10 kilometers. So between the bandwidth that's needed on the optic and the relatively short distance, direct-to-tech technology is generally used 100% within the data center. When we take a look at between data centers and central offices, regional, metro, long haul, sort of like above 10 kilometer out to thousands of kilometers transmission, we see the deployment of optical systems. And here the fiber is generally scarce. So when we say scarce, we mean if you want to make a connection between Los Angeles and New York City, you can't just pull another fiber. So what we need to do is we need to increase the amount of information we put on a particular signal, so the bit rate on the signal, as well as increase the number of signals we can put on a fiber, whether that be reduce the wavelength space in between the wavelengths and open up the other bands within the optical spectrum. And so because those bit rates are high and those distances are long, we see the use of coherent technology used predominantly in those optical systems. Next slide. When we take a look at even the bandwidth rates, when 10 gig was the majority of the optics rates that were deployed, and you take a look at the overall cost of the BOM, so a fully loaded router switch, about 10% of that cost in a fully loaded router switch was the optics cost. 90% of the rest of the BOM was the actual router switch, so the Ethernet switch silicon plus all the electronics, mechanical structure around the actual chassis. When the rates moved up to 100 gig, what we see is more of a half and half bifurcation split across the overall BOM, where the optics drove 50% of the cost and the router switch itself drove about 50% of cost. Now we're deploying 400 gig as the majority rate, and we see a flip in the overall BOM and in the spend. The majority of the spend is predominantly in the optics, and a very small portion of the spend is in the router or the switch. And that's because the port cost has come down significantly, but the expense has now moved into the optics where you need the different modulation schemes in order to get to those higher and higher bit rates. Next slide. So if you kind of start from the right side of the slide, 80 kilometers and above, as I mentioned in the previous slide, we use predominantly coherent detection as for our transmission. And then if you look at the far left side, 2 kilometers within the data center, 100 gig, 400 gig, even 800 gig, we use predominantly direct detect. When you start to increase those bit rates and increase those distances, you start to see the coherent technology creep into the shorter distances. And so what we believe, at least at Cisco, is that when you get to the high speed rates of 1.6 terabit and beyond, there's a strong likelihood that you'll need some sort of coherent detection, even to traverse short distances such as 2 kilometers. Next slide. When we take a look at the path to onboard optics, today the top cartoon, switch silicon is inches away from the pluggable module, and so we see we see the switch speed starts to increase, which drives the need for higher and higher SerDes rates, and so that optical engine needs to move closer and closer to that switch in order to meet the needs of the higher speeds. So the next step we envision is a co-packaged optics where the optical engine is embedded into a line card very close to the switch, but not directly attached to it. And then the third stage, we see that a true co-packaged optics with the switch silicon, where it's one entire co-packaged unit between the silicon photonics as well as this ASIC switch. The timing of this, we're not as sure, but I think based on my peers' slides, I think we all kind of believe this is the path forward. Go ahead, next slide. So how is Cisco achieving these next generation of technologies? We do build, buy, and partner, and so we do have teams within Cisco that take a look at how to develop technologies and products in-house as our build strategy. But we also leverage both acquisitions and investments in the core hardware segment, so for optics and silicon. So since 2010, we've been investing through acquisitions. In 2010, we acquired Core Optics, which was our first generation coherent technology. We complemented that team with the acquisition of Lightwire in 2012, which was the first generation silicon photonics platform. In March of 2016, we acquired Liba, which is for the next generation of routing and switching Ethernet switch silicon. And this is the platform that we are building our Silicon One, our business around silicon, switch silicon. In 2019, we acquired Luxtera, which is the next generation silicon photonics platform that also leverages manufacturing processes that they have developed and put in place. And then in 2019, and then again in 2021, we announced and finally closed the acquisition of Acacia, which brings in coherent technology, next generation coherent technology. But in addition to that, Acacia brings us the packaging, the co-packaging of the coherent DSP with the next generation silicon photonics platform. We also invest directly in optics and silicon, but we tend to keep those investments confidential, and so we've made a number of investments that help us decide how we want to either build, partner, or buy in silicon and optics. And as an example, Liba, the company we acquired in 2019, that was a company that we were an investor in for 5 or 6 years prior to actually acquiring them in 2019. Across Cisco, we always take a build, buy, partner approach. The partner can be either investment, joint venture, or just a partnership, supplier-customer partnership. But in every acquisition, we take a look at that build, buy, partner strategy and decide what is the best path for Cisco to execute on their strategic plan. So we don't always acquire, we don't always invest, but we do take a look at the strategy. And some examples of partnerships that we've done is with Google Cloud, or things like joint ventures like Inspur. And then next slide, please. As far as acquisitions go, we've done 226 acquisitions in about a 30-year period. That is on average about 10 to 12 acquisitions per year. In the recent years, most of our acquisitions have been focused around software and SaaS, but we're still very much focused on making sure we're driving the technology edge in hardware and optics and silicon. And I think the previous slide that shows our acquisition strategy in optics and silicon reflects that. We're a serial acquirer in terms of taking a look at what what type of teams and companies we look to acquire. Sometimes they're small, 1, 5, 10 person teams where we want to actually bring in strong talent to augment our existing team. And sometimes they're very large scale platform acquisitions where that acquisition comes in and essentially becomes a new or part of the majority of a business unit. Next slide. And then Cisco is also a very active investor. We have about 2.5 billion AUM today that's spread across 120 active portfolio companies, 55 LP positions in 27 countries. We invest about 250 million annually per year across new investments as well as follow-ons. Our LP positions are predominantly geo-focused. So when we want to take a look at how do we want to enter or grow an emerging market from a geo perspective. And we also invest in technology themed venture funds, such as industrial IoT. We've been investment in McRock's Fund 1 and Fund 2, as well as silicon and optics related investments, such as Walden Riverwood, which is now Celesta Capital. They're funds that are semiconductor focused, and a recent investment that we've made in another semiconductor fund based here in the U.S. So we try to leverage our balance sheet to do acquisitions, joint ventures, and investments to enhance what our business units are doing as far as driving growth and being a technology leader across Cisco, but especially in the core hardware, silicon, and optics segment. So that's all.
Thank you very much, Kay. I know you are having a hard stop. Let's bring in the whole panel. So let's start the Q&A session. I know we are a little bit running short on time, so we do have over 400 participants joining us today, so it's a pretty good turnout. Really, thank you for wonderful discussions about your view for the future. So let's start some questions. There's actually just one question practically for everybody. Look, there's actually recent shortages of semiconductor. I guess in our panel here, we do have both the provider and users. How do you deal with recent semiconductor shortages? How about share your view with us? I guess Dr. Hong Ho, you are making everything yourself, or do you also?
No, we're not making everything ourselves. We make most of the things ourselves for optical components, but we still have to buy power ICs and work with our contract manufacturers for putting things together. Yeah, so all of a sudden everything is in short supply. We have heck of part to get power IC parts and specifically name the name of the company. I mean, and they seem to be really running into a very short supply, and then the COVID doesn't help with the entire supply chain. So you very often hear, oh my gosh, our contract manufacturers, our OSAT, our farm is running, at a 48-hour shutdown because of the outbreak in some areas and get flared up. It is a very challenging environment. I don't think there is secret on that, but we are running, at Intel, so-called a task force mode. Basically, I had a war room to really look at its material shortages, and we're able to most of the time get the supply, but pay a very hefty price. So if you have these days a lot of TI components, you may make a lot of serious money.
Thank you. How about Lee?
Yeah, I concur with what Hong just said, and it is a tough situation for companies. Yeah.
Okay. Let me bring in one question from the audience, from Vincent, actually, Facebook. Dr. Hong Liu, he has a question for you. To be backward compatibility, it looked like you listed at least 2 generations This question is, do you think there's a cost concern or design complexity for 2 generation of backward compatibility?
So is this question for me?
Yes.
So there is no cost concern. So pretty much the same component you can run at a slower data rate to be backwards compatible with 2 generation. There is some design complexity in terms of make sure the optical spec is compatible with the 2 previous generations.
All right, thank you. Question for Li Xu here. Look like you have both operation, heavily in US and in Shanghai. You're probably uniquely positioned to look at a company like a US company versus Chinese company versus hybrid. What is your view there in terms of, you seem to have a unique position there as a hybrid?
Yeah, this is a question that we're kind of contemplating kind of over the past years, right? And we see our US kind of R&D certainly give us a lot of advantage, right? And for example, most advanced products are still these days first used in US, right? First conceived in US. And a lot of the advanced components, right? Whether it's ICs, lasers, or in this case, silicon photonics from Intel, are also developed in US and Europe, right? And and lots of our engineers are very innovative and they have multiple industry experience. So whenever there is a new challenge, they often can bring cross-discipline kind of solutions together to resolve those problems. So that's our advantage here in the US, in addition to general like R&D and kind of university and strong startups. But certainly China has a lot of strengths also, right? And it's increasingly so. Certainly our manufacturing of complex product in Wuxi helped us a lot in the past 10 years. And the engineering resources are helping us doing fast ramp up and reducing the cost in a very fast mode, right? That certainly helped us. And in terms of R&D teams there, they also have their advantage in terms of close to production, right? And close to a lot of the kind of supply bases, right? And there is indeed abundance of well-trained, hardworking engineers in China. In optics these days in the US, there's not many new engineers, right? And in China, there's still, fresh blood. So another advantage I see the Chinese, China-based company has on transceiver field is they have, relatively easy access to a lot of capital. Right? For example, recently, the past few years, Light, Optical, and quite a few other companies went public, right? And they Chinese or China's capital market seem to be favoring kind of manufacturing companies more than US companies, right? And so that's why you're seeing Light, they have $1 billion kind of revenue, and they can start to raise $400 million in fresh money to invest in R&D and capital equipment. So that's certainly a good advantage, and it will help them strengthen their capabilities. So that's the few things.
Thank you.
Think. Hong and Honglu and Hong Ho both have very unique perspective. I'm sure they can share their perspective.
Yeah, two of you want to comment about this? in terms of both competing, but also, well, actually for Hong Ho, more of a competing to some extent. For Hong Li, really is supplier, right? How do you see the supplier landscape shaping up, both from China and then U.S. sourcing?
So I work with both companies and a company in both countries, and I found the strengths and the weakness, and they sort of complementary with each other. U.S. companies, I think they're very good making parts from 0 to 1. But when you want to really scale from 1 to like tens of thousands, Chinese company rock. It's really operation scale and efficiency. I think it's hard for U.S. company to compete in operation and in this area.
Yeah, I agree. I think, it's just judging from the audience for today's seminar, webinar, how many engineers with a Chinese heritage, and so certainly very talented, very hardworking, and also have the very strong talent pipeline out there and viewed as also rising industry. So here, probably, people are more going to the software, the AI, more the sexy area. And for Intel, in a few areas, we are having major presence, and our competition is establishing the same function as well. We have a lot of competition, say, in the Bay Area, in Oregon, in Arizona, and in India, in Israel. And right now with the geopolitical situation, I think, we feel this is really a great opportunity. We have to gamble a little bit to see how the wind is going to blow in the future. But there's tremendous amount of talent in China, especially in the optics industry. And it's just they move so fast. I definitely agree with Hong Liu. There's a lot of times here we say we work hard, and they have different meaning. Work hard in China, and things turn around just so quickly. So certainly will be a great combination to have the presence in both U.S. and China to play the strength of different geo locations.
Yeah, thank you.
Hong and Hong, if I may add, that's why we keep teams in US and China. We hope to leverage both sides of the strength.
Yeah.
Right. Great. So obviously, there's one question from Gang Fu Wan. I guess Dr. Hong Ho also can answer the same question. Basically, is this pluggable versus CPO? I think this is a hot topic for OC itself. There are many discussions, how the CPO can come into play and when and where. So maybe both of you can elaborate a little bit about your position. And maybe that it's not a black and white answer, but it's more nuanced. It depends on what you want to do. But please take the opportunity to further comment about the CPO versus pluggables.
Yeah, Hong, why don't you go first?
Okay, so I think for the networking, like data center networking fabric, is a heterogeneous network, and we need to provision different optics at a different layer. So CPU doesn't have the flexibility. And for machine learning, I think it's more homogeneous network. So CPU might have opportunity there, but most of the power consumption in TPU or machine learning, it's in the compute where you move data around. So optic power is a very small portion of a machine learning system. And also machine learning, I think the number one requirement is time to market. So we get optic ready, and the chip comes in and just plug in and run. And if you have CPO model, you're putting the whole it's $1 billion business. You put the whole program on the risk. Nobody is going to bet CPO for machine learning system.
Okay, thank you.
Yeah, so I agree. I think this really, we're not necessarily advocating for one versus the other, but we're embracing all different standards. I totally agree. We have quite a bit of runway on the pluggable optics. And so it's more, kind of like a space and power limitation. But we get a chance to work with the many different companies. some of the data center architecture is very different. So certainly, even 50 watt of power means a lot to them. Kind of like it's almost in a way it's a digital. They can make a 16-layer stack, or they can make 8-layer stack. The data center density and capacity. So what our goal is to make it ready for both ends. Certainly the pluggable optics, you have the flexibility, interchangeability, and serviceability, all of that. And the co-packaging in the form of just a co-package with switch or other ASICs or XPUs, it's going to happen sooner or later. It's just absolutely there are advantages out there. And so our view is that we wanted to work with the industry player to establish an ecosystem, because in order to be adopted in scale, in these days, no one is going to be wanting to bet their farm on one supplier only. So they wanted to make sure that there is a system, there is a multiple players, and they can offer the same thing. So it will still be a while to get into the volume deployment. But as I mentioned, silicon photonics definitely shows more advantage when the channel counts more, when you have more components that need to be integrated, but it doesn't have to be. That's my view.
And some of the technology that we develop for CPU can be very useful for application like inside optical transceiver, electrical and optical co-packaging, tight integration can actually improve the power efficiency, simplify the manufacturing process, and you get better electrical performance. The TI sensitivity is better. The driver has higher swing to drive laser and the modulator.
Yeah, so Han, you more talking about CPO, but it's a smaller granularity, but it can be leveraged for transceiver as well, right? That's your key comment.
Yeah, definitely. The technology developed for CPU can be leveraged for other places like inside optical transceiver, and also maybe on the neck where you have one port and you have optical co-package, and then the whole thing treated as a FRU. If the optics has a problem, just replace the whole card.
Thank you. There's one more question about the computing side. Obviously, there are some controversy discussion about using optics or silicon photonics in specific for compute. This is seen to be a controversial issue. Like, is it real technology, or is it really a technology looking for a problem to solve and not necessarily meaningfully solve the compute problem? What's your view, both Dr. Hong Ho and Han Liu?
Yeah, so we dabble around the optical neural network. So using the silicon photonics to build an analog circuit. And that is a little different. Optical computing sounds, has been a term used for 30 years. I remember when I started at Bell Labs in 1993, my next door neighbor is Alan Huang. For those of you have been around, he was the father of the optical computing. So I asked Alan, should I wait of buying my 486 or should I wait for buying an optical computer? I'm glad I bought a 486 at the time, but the optical computing is what I mean is only part of it. The optical neural network, which can be built with the silicon photonics analog circuit.
Can it even be real for specific AI applications?
Yeah, definitely. I mean, there are quite a few very innovative startups in there, Light Matter, Light Intelligence, and QSI. Quite a few companies are doing the ONN with the silicon photonics.
Dr. Hong Liu, do you have any comments on
that? So in general, I think optics is not good at computing. It's analog in nature. Doesn't have the resolution to do complex computation like electronics. Okay. We look at that carefully because we get a lot of inquiries from our machine learning systems on this like hot startup company. We look at things from fundamental, just doesn't have the resolutions to do the complex model we need.
Yeah, so this is an interesting area I think we're watching. There's actually a commentary, a talk by Chris Cole. Many of you know him. He basically making a statement. Most of the gain actually is from optical I/O. So most of these people making a statement about how energy saving is from optical computing is really from saving from the I/O. So this is still pointing to a promising direction. If you do use optical I/O properly, you can really save power. I think Dr. Hong Ho, you point out earlier, right? You can actually, if you properly integrate closely with optical I/O, you can really save the power, and that's where you're moving, data back and forth. That's where the power is.
Yeah.
So another problem of photon doesn't have a storage capability. So you move the data you have to store, so you still have to go back to the electronic domain to store the data. Right. It's more than just move data around, right?
Yeah. Thank you. I do have one more question. There's a 200G looming and coming. Any venture to guess from all of you? When you think gonna deploy 200G per lane in like rough time scale?
On your roadmap, you showed the volume deployment in 2024, right?
So it's waiting for the 3 nanometer, 200 gig SerDes in 3 nanometer. We think the mature date for that is probably 2023 initial sample and the 2024 production, volume production.
Right. Well, that's the end user speaking. So I guess Ali and Han, you have to map it out. Right?
That's right.
I seem to miss Ming Sun. Dr. Shunming, are you online still?
Yeah, I'm on. Yeah.
Okay, yeah, I haven't heard you speaking. How about your side of networking view? I saw you talking about 128 port. Look like that's the radix you are doing with your networking. Like at 128 ports is kind of where you prefer to see. That's why you are not eager to move at a higher rate, because you basically have enough. You need to fill the radix with a switch capacity.
Actually, as architecture decided the style, the shape of the switch. You mean the 128 port for switches?
Yes.
Okay. Yeah. We for a long time we use 128 ports for one switch. More than I think 10, 8, some of that years. Yeah. I think for later we could also follow this standard, I think. So that means you just talk about co-package. That means we won't use co-package for the future 10 years. As maybe 800 for port, maybe at 2028, 2029. Yeah, I think.
Okay, thank you. There's one interesting question from Jen Chen. There seems to be a recent movement on the company like Google moving to the edge computing and edge data centers, etc. So there's interesting dynamic how the, I guess, traditional service provider collaborate but also compete for sort of moving the network to the edges. I don't know, any of you have comments both from Dr. Hong Liu and Ming Sun from, I guess, web company point of view, data center operator point of view?
So we have been using Edge for content distribution, CDN. So especially like YouTube, right? So if you want to have provide the bandwidth to the users watch the video. We prefer to cache at the edge so the traffic doesn't go through the data center, which is more expensive. We partner with ISP to have the content cache at the edge. Now, because we are ramping up the cloud, we want users to have better experience in terms of latency. We do have data center at the edge.
Right, with the 5G coming, obviously there are promising many new applications which have latency requirements and a slicing of different services. So obviously this is an opportunity for a web company because you are very software intensive and capability there to help out. So I guess, is there opportunity for even a company like Google to become really growing in the traditional service domain of telco companies?
We do. We have a Project Fi. We partner with T-Mobile, right? So to offer wireless service to end users.
Right. Yeah. So, Minsheng, Tencent have any ambition there to?
Sorry, Doug, you mean Edge Computing?
Yes, Edge Computing,
data center.
Cloud.
We also tried the Google Fiber, but it didn't take off.
Yeah, you don't like the last mile. That's hard business. So just leave that last mile to a telco company, take the rest. Right?
Okay. From my point of view, actually, Tencent is application first. It's a company of application first. So if you don't see any application, you won't use edge computing, edge data center. But we are investigating in this domain. So I couldn't say we won't use edge computing, edge data center, but maybe later. Yeah.
Okay. Yeah, thank you very much. I think really appreciate you stay late here. We really are a little bit overrun in our workshop, but it's really wonderful to have all of you joining us and spending time. Like I said, that we actually have over 400 participants at this workshop. So we probably can say this is one of the largest workshops during OC session. Yeah, thank you. Really appreciate. Sam, should I hand it over to you now?
Yeah, I'm so happy. This is a great workshop, and I'm quite sure, right? So the people stay, they are all the diehard fans for our community. Yes, actually, I missed the opportunity, right? So missed opportunity as this year as a president, I want to just hand over this flag to appreciate you gave this very insightful presentation and the guidance for the industry. So I missed the opportunity to take a photo picture with I call the celebrity of industry. So for a moment, if I wear my daily job hat, managing current DSP in Marvell, I got a lot of pressure based on your discussion, right? So power, size, performance, current technology sounds like that's the way to go moving forward. And but it's really appreciate, and I will figure out a way, maybe get a local meeting with you guys, and
we owe you a big dinner.
And the other one is that's
really so physically meet together.
We don't have the traditional big dinner after this this meeting, and but really appreciate, and so this is show your dedication, your really help this community, and it's very valuable. Thank you. And Frank, one last page. Yeah, so just want to wrap it up. So we very successful. I noticed at the peak time, as Ryan mentioned, at the workshop, we have a 400 strong, 411, 12 people shown up. And definitely it's the largest, I believe, for this year OFC, all the workshop. And so appreciate all the people participate, and hopefully you also enjoy all the talk, all the conference, provide all the information. And so we just want to announce next year for PSC president, Dr. Ryan Yu will take the baton, and we set the bar pretty high this year. But I'm quite sure he will continue drive and help the community to grow and all benefit. So just on a call for this conference. Thank you all, and hope to see you physically next year in OFC.